Hi, I'm Ken, I'm a maths tutor, and this is a short video on how I teach factors, multiples and primes. If you look in the description, there's also a link to a worksheet where you can have a go at this for yourself. So hopefully this video will help you to do it. So factors and multiples are quite a simple topic, but the issue normally is that students get confused between which one's which, because they're taught at the same time and they are quite closely related. So we'll start with factors. Factors are numbers that go into a number. So for the number 30, it's any number that goes into it. So when I ask students this, normally they know what factors are, and I'll ask them to find all the factors of 30. And what they'll start doing is they'll start giving me numbers like 5 and 10 and 3, which are all correct, but they normally struggle to find all the factors. So what I'm going to show you first is a method for finding all of them. And what we're going to do is we're going to be systematic. What that means is we're just kind of going to go slowly through it, kind of in a boring way, but just make sure we get all the factors. So for 30, we should all, with whatever number we're doing, we should always start with 1. 1 is a factor of every number. And we're going to pair it off, like how many times does 1 go into 30? Well, this is quite easy. 1 goes into 30 times. So 30 is also a factor. And we're going to work our way up from 1. We're going to try every number. We're going to try 2, we're going to try 3, we're going to try 4, and we're going to stop when we hit a number we've already got. So, and that will become clear when I do it. So next number we'd try is 2. 2 does go into 30 because 30 is even, and it goes in 15 times. The next number after 2 is 3. 3 goes into 30 10 times because 30 means 3 tens. The next number we try now is 4. 4 doesn't go into 30, so we're not going to try that one. We're going to skip it. And then next is 5. 5 goes into 30 6 times. And the next number we try after that is 6. And if you look, we've already found 6. So we can stop here. We found them all. If we carry on, we're going to end up getting 6 and 5, 10 and 3, and just finding the same numbers. So that is us done. We have found all the factors of 30. There are 4 pairs, and there's 8 factors in total. Now, multiples are different. Multiples of 30 kind of means the 30 times table. So multiples of 30 would be 30, 60, 90, 120. Kind of like the 3 times table, which exists here, but with a 0 on the end. So those are multiples. Now, we couldn't find all the multiples of 30 because there is no limit. We could keep going and going and going. And that's the concept of infinity. So ways of remembering, which is the most key thing here, which one's which one's a factor, which one's a multiple. You can never be asked to find all the multiples. You might be asked to find 1 or find 3 of them, whereas you can be asked to find all the factors. Let's do this again. We'll also talk about other ways of trying to remember this. So say we do it for 40. We've got factors and we've got multiples. Now, factors is the smaller word, and it also gives us the smaller numbers. It gives us numbers smaller than 40, also including 40. Multiples is the bigger word. It's got more letters, and it gives you the bigger number. So multiples of 40, we get big numbers. We go up from 40. Whereas factors of 40 are all smaller than 40, apart from obviously 40. So again, we'd be systematic. 1 and 40. 2 goes in 20 times. 3 doesn't go into 40. So being good at your times tables is helpful here. 3 doesn't go into 40. 4 does. It goes in 10 times. 5 goes in because 10 goes in. 5 goes in 8 times. Our next number would be 6. Now, because 3 didn't go in, 6 isn't going to go in. So we can rule that out. And then we try 7. Again, you just need to know your times tables here. But 7 is not a factor of 40. So we're going to ignore that. And then our next number would be 8. Now, if you notice, we already found 8. So if we carry on here, we're not going to find any new factors. So we can stop. So 40 has got 8 factors. Again, if we were to carry on the multiples, there is no limit. So that's how we do it. So the important thing really is, what is a factor? Trying to get it in your mind what it is. It's numbers that go in. Multiples is like multiplying 40, or multi-packs if we were buying crisps in a multi-pack of 40. You could buy 80 packs of crisps, 120 packs of crisps. So it's just trying to find a way to link it in your mind so that you know which one's which. It's probably the most important thing there. Let's talk about why, for instance, if we did 15, factors of 15, why don't we count 2 as a factor? Because 2 does go into 15, but it goes in 7.5 times. So to be a factor, it's got to go into it and give you a whole number. It's got to give you an integer. So 2 and 7.5 aren't factors. 2 isn't a factor. But we would have 3, which goes in 5 times. 4 would be next. 4 can't go in because 2 didn't go in. And next would be 5. So we're done there. 15 has got far fewer factors than the ones we did before. And that brings us on to prime numbers. So a number like 11 is a prime number because we start off with 1 and 11, and there are no other factors. 2 doesn't go in, 3 doesn't go in, 4 doesn't go in. So no more factors. So to be prime, it has 2 factors. And I hear from students all the time, a prime number can only be times by 1 itself. That's not correct. It can only be divided by 1 itself. Again, not correct. We can divide 11 by 2. It's just not a factor. So a prime number has 2 factors. So that's key. And our prime numbers, if we look at the first 10 numbers, there's quite a lot of prime numbers early on. I've got 8 on the screen there. So let's start with 1. 1 has only got 1 factor. It's a square number, so it's not prime. It's got to have 2 factors to be prime. 2 has only got 1 and 2 as factors, so it is prime. 2 is an important prime number. It's the smallest, and it's also the only one that's even. No other prime number can be even because, for instance, 4, because it's even, it's not just 1 and 4, it's also got 2 as a factor. So actually what we can do is we can cross out all the even numbers here. None of them will be prime. 3 is prime because the only factors are 1 and 3. 5 is prime because the only factors are 1 and 5. And 7 is prime, again, because they've only got 2 factors. If we'd carried on and gone to 9 and 10, again, I'm going to cross out 10 because it's even. 9 feels prime, but actually it's also got 3 as a factor. So it's not a prime number. It's a square number. So 9 isn't prime. So those are the first 4 prime numbers. They get increasingly further apart. And the way to check whether a number's prime is, does it only have 2 factors? Okay, so have a go at my worksheet. I've put in the description. There's solutions there as well. And hopefully that'll help you how to find factors, multiples, and primes.